everybody, and welcome back to another video of mathematics. These videos are all geared towards helping you to become better prepared in your exam, whether it be next year, the following year, whenever you're sitting the exam. So far we have been covering a series of algebra, and algebra is one of the main topics in mathematics, in CSEC. Algebra forms as the foundation of all the other topics. Algebra is in everything. So you must have a firm understanding of algebra, and we'll continue to do that in this video. So we'll be adding a little spice into something that you already know about, which will be fractions. So the spice that we'll be adding to the fractions will be algebra. So today's topic is algebraic fractions. And at the end of this video, you should be able to do a few things. You should be able to add and subtract algebraic fractions with the same and different denominators. You should be able to simplify algebraic fractions after addition or subtraction. And then you should be able to solve problems involving addition and subtraction of algebraic fractions. So let's head straight into the content. So of course, let's recap with what you already know about fractions. Forget about algebraic fractions. Let's just focus on normal fractions. So let's say we have 1 over 5 plus 2 over 5. So we know when we're adding fractions and the denominators are the same, what do? We simply put back the denominators and we just add the numerators. We add the numbers at the top. So in this case, 1 over 5 plus 2 over 5, we see the denominators are the same. So we put back the denominator, which would be 5. And we just add the 1 plus the 2, which would give you 3 over 5. Let's look at another example. Let's say we have 2 over 3 plus 1 over 6. So in this case, we see the denominators, they are not the same. So what do? We find the LCM. We know that we have to find the LCM. So we find the LCM of 3 and 6. So the LCM of 3 and 6 will simply be 6. And then we divide this LCM by both denominators, and then we multiply it by the numerator. So in the first fraction, we have 6 divided by 3 would give you 2. And you take that answer and you multiply it by the numerator. So 2 2s would give you 4. Plus 6 divided by 6 would give you 1. And we take that answer, we multiply it by the top there. So 1 times 1 would be 1. And now we have 4 plus 1 would give you 5 over 6. So when we add 2 over 3 plus 1 over 6, we will have 5 over 6. When the denominators are not the same, we find the LCM and then we multiply and then multiply. So the beauty about algebraic fractions is that these same rules that apply to normal fractions when we're adding and subtracting, the same rules will apply to algebraic fractions. And that is the beauty about mathematics. You know, one rule will transfer to the other. So let's look at our first example. Now these questions, when you're asked to simplify algebraic fractions, the question will say, write as a single fraction. All that means you have to perform whatever operation they're asking you to do and simplify it. When you have some algebraic fractions and they say write as a single fraction, you just add, subtract, multiply, and then you simplify. So let's look at the fourth example. So we have x over 3 plus y over 3. So in this example, we see the denominators are the same. So all we do, we put back the denominator, which would be 3, and we add the numerator, which would be x plus y. So we see x plus y would simply be x plus y. We cannot take it any further. So when we simplify, when we write x over 3 plus y over 3 as a single fraction, it will simply be x plus y all over 3. So let's look at another example. Let's say we have 5 over x minus 3 over x. So once again, we see the denominators, they are the same, which would be x. So we do the same thing. We put back the x and then we subtract the numerators in this case. So we'll have 5 subtract 3 would simply be 2 over x. And we can subtract 3 from 5 and that will give you 2. So that is how you deal with these simple examples. So let's take things up a bit. Let's look at them now when the denominators are not the same. So let's say we have 2 over x plus 2 over y. So in the first fraction, we see the denominator is x, and in the second fraction, we see the denominator is y. So we have to find the LCM of the denominators, which would be x and y. So the beauty about finding LCM of fractions, an easy way to do it, is simply just to multiply the denominators. That's an easy way to do it. Multiply the x by the y. So we see x times y would simply give you xy. So the denominator, the LCM, would be xy. And then we do the same thing like what we did just now. xy, and we divide xy by x. So xy divided by x. So this x will cancel with that x, we're left with y. And we take that answer and we multiply it by the numerator. So this will be 2 times y. And 2 times y would give you 2y. Plus xy divided by y. This y will cancel with that y. And we take that x and we multiply that by 2. So 2 multiplied by x would give you 2x. And that is our answer when you write it as a single fraction. We can't take it any further because 2y cannot add to xy because they're unlike terms. So our answer would be 2y plus 2x all divided by xy. Let's look at another example. Let's say we have 5 over a subtract 2 over b. So we see we have the denominator for one is a, the other denominator is b. So we have to find the LCM. They're not the same. So the LCM of a and b would simply be ab. Just multiply them. ab. ab divided by a. This a will cancel with that a. We're left with b. So we take that answer and we multiply it by the numerator. So 5 times b would be 5b. Subtract ab divided by b. The b will cancel out, so we're left with a. So we take that answer, we multiply. So 2 times a would give you 2a. And we leave it as that. We cannot take it any further. So our answer, when we have 5 over a subtract 2 over b, would simply be 5b subtract 2a. All divided by ab. And that is the answer. So now let's take things up a bit. Let's take things further with some more examples. Let's say we have number 3. 5 over 2x plus 3 over 3x. Now in this case, we have 2x and 3x. Of course, the denominators are not the same. 3x is not the same as 2x. So we have to find the LCM. Now a trick in finding the LCM when we have a coefficient and a variable. The trick is to find the LCM separately. So let's look at the numbers. Let's look at 2 and 3. So what would be the LCM of 2 and 3? So we know the LCM of 2 and 3 would be 6. And then we look at the variables now, x and x. So the LCM of x and x would simply be x. That's the highest common factor. X and x would be x. So the LCM of 2x and 3x would be 6x. They were the numbers for us and then the variables. And then we do some division. So 6x divided by 2x. This x will cancel with that x. 6 divided by 2 is 3. So we take that 3 and we multiply it by here. So 5 times 3 would be 15. Plus 6x divided by 3x. This x will cancel with that x. 6 divided by 3 would be 2. We multiply that there. Multiply that 2 by the top there. So 3 times 2 would be 6. So 15 plus 6 would give us 21 over 6x. And we cannot break that down any further. So our final answer would be when we have 5 over 2x plus 3 over 3x would be 21 over 6x. So let's do another example. Let's say we have a plus b all divided by 2 minus 2 over 5. So let's not get carried away. Let's not get carried away with anything. The same steps apply, the same rules. So we see the denominators. We look at the denominators 2 and 5. So they are not the same. So we find the LCM of 2 and 5. So the LCM of 2 and 5 would simply be 10. And then 10 divided by 2 would give you 5. And you take that 5 now and you multiply it by the numerator. So we see the numerator here is a plus b. So we have to multiply this a plus b by the 5. So this will be, you have to distribute this 5. 5 times a would be 5a. And then 5 times b would be plus 5b. And this will subtract now. 10 divided by 5 would give you 2. We take that answer and we multiply it by the top here. So 2 times 2, that would give you 4. So we have at the top 5a plus 5b subtract 4 all over 10. And that would be the answer when we simplify a plus b over 2, subtract 2 over 5, and we write that as a single fraction. We cannot take anything in the top any further because they are unlike terms and there's nothing else to add and subtract. So that will be our answer for that one. Same rules apply. So now let's look at the final example. So the final example says 3 over 2x minus y over 3xy. So of course, we have to find the LCM because we see 2x is not the same as 3xy. So we find the LCM of those two denominators. So we take the numbers first, 2 and 3. So the LCM of 2 and 3, we know that will be 6. And then we find the LCM now of the variables. So we see x and we see xy. So we see x is common. So we know we put back that as an LCM and we just bring back the y. Now we divide. So we have 6xy divided by 2x. So this x will cancel out with this x. 6 divided by 2 will be 3. So this answer will be 3y. So we take that 3y and we multiply it by the 3. So 3 times 3y would be 9y. Subtract 6xy divided by 3xy. This y will cancel to that y. This x will cancel to that x. 6 divided by 3 will give you 2. So we take that 2 and we multiply it by the numerator, which is y. So this is multiplied by 2. So y times 2 would be 2y. So 9y subtract 2y would be 7y, all divided by 6xy. And of course, we had to subtract, we had to simplify the 9y minus the 2y because those two are like terms and we cannot leave like terms as that. We have to simplify it further. So 9y subtract 2y would give you 7y, and all of this over 6xy. That is what happens when we express 3 over 2x, subtract y over 3xy as a single fraction. And I will leave this one for you to try on your own. So it's 2 over y plus 1 plus 3 over y minus 1. So this is one you can try on your own. And with that, it brings us to the end of this video. And I trust that after this video, you're now more confident in algebraic fractions. So see you again in the next video.